In a previous video, we saw that we can estimate the area under a curve in this simple example, y equals x to the third, over the interval 0 to 1 by breaking the interval up into any number of equal subintervals and then estimating the area by adding together the common width times all the heights of the right endpoints, the functional value at the right endpoints from 0 to 1. And in general, if we looked at simply any number n rectangles, we got that the common width of all the subintervals that we had was 1 over n width, and that the heights were the numbers from 1 up to n. In other words, 1 up to n of all the I values, being the numbers 1, 2, 3, 4, 5 on up to n divided by n, with the functional value being I over n to the third, the function y equals x to the third. So the heights for each of the rectangles was I over n to the third. And then by solving this, we could factor out the n's, 1 over n to the fourth, and then we had a formula for the sum of the first n cubes, which is n squared, n plus 1 squared over 4, and then allowing the number of subintervals to increase without bound, we end up arriving at the actual area, this limit being 1/4. Now, the fundamental theorem of calculus states that if you have a Riemann sum, the sum of any number of rectangles with heights f of c sub I, where c sub i's are the values in each of the n subintervals times a common width delta x, that limit as n becomes an infinite number of infinitely thin rectangles, that becomes the area, the actual true area under the curve, and that the fundamental theorem of calculus states that that would be equal to the definite integral from a to b of f of x dx, where this again is the height times the width, the height being the value of each of the subintervals evaluated at x to the third times an infinitesimally thin dx for each of the infinitely thin subintervals, that would give you the area under the curve. Well, let's see what happens when we do this. The definite integral should be the area, the definite integral from 0 to 1 of the function, the height, x to the third, the height is x to the third, with the width being dx. Simple example, 1/4 x to the fourth, evaluated from 0 to 1, which would be 1/4 minus 0, or 1/4. And what do you know? You get the area under y equals x to the third over the interval from 0 to 1.